Right, so here's an identity question that links into a trig equation, and I suppose what we could do at the side is just write down the two identities that we'll be using. Well, this is theta, right? So why don't I just actually use theta as the variable? That'll be a little bit easier, right? And also sine squared theta plus cosine squared theta is identical to 1. We should really put 3 arrows there, 3 lines there, okay, identity. And so let's go ahead and work on this. Now there's a left-hand side and there's a right-hand side. And the idea is to work on one of the sides exclusively and try and turn it into the right-hand side. And it doesn't really matter what side you start with. I mean, some advice is that you start on the side with more pieces, right? This has got more pieces, it's got more scope to work with. Possibly, but you can start on the left-hand side. But I'll take my own advice. I'll start on the right-hand side, okay? So we're going to make a little note to the reader, right-hand side. I'm going to write down the actual right-hand side, and then we're going to go ahead and manipulate it. So this right-hand side is identical to 3 minus 3. And I think the big clue is that we're trying to get rid of the sine squared and transform it into cos squared. And look, there's an obvious identity we can use here, okay? So the rearranged version of this, and again, you'll get used to using the rearranged version, okay? And then we just go ahead and we substitute in. So that's 3 into 1 minus cosine squared theta. So that's identical to 3. We expand the brackets now, minus 3, and then plus 3 cosine squared theta. The 3's cancel out, and we have 3 cosine squared theta. Go ahead and clean it up. That's identical to the left-hand side. If you want to be fully fancy, the little black square from Paul Erdos. Very nice, right? It's probably going to delete on me. Fantastic. All right, so that's part A done. Now the key word here is hence, all right? So in mathematics, this hence means that take the previous answer and use it in this question, right? So we have to use the previous answer. So let's go and have a look at the previous answer and see what is it about the previous answer that we can use, all right? So I'm kind of seeing the 3 cos squared theta here, and I'm seeing the 3 cos squared theta here, and we are going to substitute the 3 minus 3 sine squared. And that makes sense because as we look at the equation to solve, it's got cosine and sine. So we kind of really want to get that into all sine or all cosine, right? All cos or all sin. And so this is telling you that we can replace the cosine piece with a sine piece, right? So let's go ahead and do that and see what we get. So 3 cosine squared theta we replace with 3 minus 3 sine squared theta. And then everything else, right? Everything else just gets written down as before. Okay, it can keep to the left-hand side. Usually we write in decreasing powers of sine theta. I'm going to be a bit cheeky and do 2 steps in one there, right? Subtract 1 from both sides. And actually, I'm now going to times both sides by -1. Okay, and now I'm going to factorize this. You will get used to factorizing directly with sine theta, but for now, a little substitution might be helpful. So let x equal sine theta. And now this will look a little bit more familiar. 3x squared plus 5x minus 2 equals 0. Yep. And now the trick is to try and factorize this. Now there's all sorts of techniques for factorizing quadratics. But because this lead term of x squared is 3, well, it has to be 3x and 1x. And because this final number is 2, it has to be 2 and 1. And you can put 2 and 1 like this, or you can put 2 and 1 like this. And you've kind of got to test both out. Now, one of these numbers has to be a negative and one has to be a positive, okay? So if I put negative and a positive here, we will test the middle terms. This will be 1x minus 6x, which will be minus 5x. So we're nearly there, we need plus 5x. So if we go ahead and change the signs round, now can you see we actually have, when we expand, we've got the 6x minus 1x is the plus 5x. And of course, we're guaranteed to get the other pieces because that's how we set up the first terms in each bracket, right? The first terms in each bracket and the last terms in each bracket. Okay, so now we've got this far. Let's go ahead and solve, and then we'll go over the next page to get the final answers. So either we make 3x minus 1 equals 0, so that's x equals to 1/3, or we make x minus 2 equals 0, and that's x equals to 2. Now let's go on the other page. So we had x equals 1/3, or x equals negative 2, but x represented sine theta. Oh, my bad, x equals to sine theta. Now when we see this here, remember sine theta is basically the percentage of maximum height, and sine theta is only between -1 and +1. So there is no answer for this, right? There is absolutely no answer for this. So we say theta undefined here. So while this is definitely a correct solution for the quadratic, it doesn't yield any solutions, okay? Now for this other one, we're just going to switch to our calculator, right? And we are going to do inverse sine of 1/3. So I'm just doing that in my calculator. I've got 19.5 degrees, right? So theta equals inverse sine of 1/3. And I've got 19.5 degrees. Now, if we look back at the question, we see the domain for the solutions is 0 to 360. So I'm going to do this in two ways. I'm going to do the kind of cheat way, really, or the memory way. This is the principal solution, and 180 minus the principal solution gives us the secondary solution. All right, so the second solution is 180 minus 19.5 degrees. And that's equal to 160.5 degrees, right? So that kind of works most of the time, but also we've been playing with the idea of the Ferris wheel and also the unit circle. And so I'll show that way as well. So we've got a 19.5 degrees. Let's go ahead and put that as a solution in here. All right. And that indeed is a 19.5. But look, sine of the angle is positive, and so we also have another arm of the Ferris wheel on the unit circle, right? This is part of the unit circle. And this is also 19.5. Now, this is your diagram to generate all the solutions. Now, let's go ahead and generate the solutions. We wanted between 0 degrees and 360 degrees, so we're positive angles, so we measure around to here and we get the 19.5, and we measure around to here and we that's not very good. We measure around to here and we get the 160.5 degrees, and that's it.